Here in Dr. Rocket, we've got the program from the slides, numbers from, which we said goes into an infinite loop in an eager language. So it takes in a number I and then builds up a list with I at the front, and the tail is numbers from I plus 1. So if we run this in Shplait, it'll run forever. So I'm not going to do that. But if we drop into Shplait Lazy mode, then we're just fine. We can run this code, and now 5 and up is a list that we can work with. Well, it's not really a list. It's more like a promise that once we ask for a list element, Shplait knows where to look to get that element. So if we say list get 5 and up, and let's get the first element, and there we go, we've got it. And if we want the second element, that should be 6. And if we ask for a much bigger element, then Shplait will do all the work that it needs to get the element that we've requested, but then it will stop and it will go no further. Let's look at another example. So now we'll start off with a boring function, f, which takes in an x and adds 1 to it. We'll call this x with an expression like 3 plus 4. In our lazy Shplait, this addition 3 plus 4 happens only after we use x inside the function body. So this whole expression gets substituted in, and it only gets reduced to the value when we ask for it. That laziness around substitution gets very interesting when we have a function that doesn't use its argument. So here's a function g of x, which just returns 4. And now if we call g with 3 plus 4, we see that 3 plus 4 was never evaluated. And that will happen even if the argument expression is an error. If we call g with 1 divided by 0, we don't see the division by 0 error. The division is never evaluated because we never asked specifically for its result. Let's see one more example. Here we're back to our numbers from function. Now let's write a function alternates, which takes every other element from a list. So input is a list of int, output is a list of int, and we'll make a const pair with the first element of the list, and then alternates on the rest of the rest. Okay, so now we're building up a new list with every other element of the input list. Let's call this on 5 and up. So if we ask for the 1000th element of our alternated 5 and up list, now we get element 2005. Started off at 5, and then we went ahead 2000 spaces, which is 1000 in our every other list. And then we're all set. This program finished quickly. It didn't go on forever. So the point here is that even when we're defining our own functions, if we're working in a lazy language, all of these calls will be lazy. So both alternates with its recursive call and numbers from with its recursive call, these both happen lazily. Back to the slides for 1 minute. So if you want to use Shplait in lazy mode, you have this option, tilde lazy. And here are the details for how to turn on test suite coverage in Shplait.